I like it. So an inverse function in general is the function that does the opposite of the original function. Good. Now, not asking for a definition. Very specifically, the output to an inverse trig function. Is it a square? Is it a line? Is it a point? Is it a number? Is it a, what is it physically, geometrically? What do you put into a trig function?
You put an angle.
Good. So what comes out of an inverse trig function? Angle. Good. So any inverse trig function I see sitting there is an angle. Are you guys with me?
I was confused on that yesterday.
Let me say this again, because this is just the reality. If I put into a trig function an angle, I get an angle out of an inverse trig function. Because what do? They switch the x and y. The input of one is the output of the other one. Is everybody with me? So whenever you see an inverse trig function sitting there, this could help you or not, but the reality is it's an angle. So number 90 says tangent of one angle minus another angle. Right? So I don't know. Would this problem be easier? I mean, this problem should be easier, but do you see how this says cosine of angle plus angle?
Yeah.
Do I have an identity to help me with like cosine of a plus b? Because that's all that says. It just says cosine of one angle plus another angle. Don't I have an identity for that? And let me really make sure you guys are understanding the motivation as to why I'm doing what I'm doing. And you're all like, that's what we're always trying to figure out, dude. That's why the shit are you doing what you're doing? If I gave you this problem, and this is in this homework, but if I gave you this problem right here, sine of inverse, tangent of 11 over 7. Holy crap, that's really simple. There. Okay. Back again. Okay. How do I do that problem? What can I draw from this? Triangle. So, inverse trig is an angle that lives in a triangle that I know stuff about. So, inverse tangent of 11/7 means whatever the angle is, the tangent of it is 11 over 7. So, which side is 11?
Y.
And which side is 7? Because tangent's y over x. Do you all agree with me that tangent of that angle would be 11 over 7? The way we set it up. So therefore, if I took an inverse tangent, theta would be inverse tangent of 11 over 7. So whenever I see an inverse trig of some ratio, I can always draw the representative triangle. Most of the time it will help me, and sometimes I don't need to do it, but I can always do it and see if it's going to help me. Do you guys see how now this question becomes stupid easy? Because now what do I want to know about this triangle? I want to know the sine, which means I need to know the hypotenuse. What's that hypotenuse?
121.
121 plus 49, which is
170.
170. So what's the sine going to be?
170. 11.
Don't think too far ahead. So 11 over square root of 170, right? Which is 11 square root of 170 over 170. Thanks. I need to remember not to look at the monitor because there's a very slight delay and it really freaks me out. Okay. You guys all with me? Anybody with me? Nobody's with me? One person's with me. 2 people. 3. So if I give you a problem like secant of inverse cotangent of 4 over 3, you really, really should go, oh, thank God. Or thank whatever your favorite, thank Flying Spaghetti Monster, thank the God of coffee, thank whatever the hell deity, or thank the universe, thank the cosmos, thank the multiverse. Whatever the shit, just go thanks. Because what can I do? From this I can do what?
Draw a triangle.
Draw a triangle. From this I can figure out what the sides are because I know it's all about cotangent. So which side's 4?
That would be
Good, x. And then to figure out secant, I just need, to figure out secant, what side do I need? Hypotenuse, that's right, a hypotenuse. So this will be, well this one is easy. I made it easy. 5. So then the secant would be, secant's cosine, cosine's 4/5, secant would be 1 over that, so secant is 5 over 4. Okay. Alright. Any question I give you that looks like trig of inverse trig, easy. I'll say this relatively easy. Okay. So, what if instead of this, I gave us sine of inverse tangent of 11 over 7, and we're like, oh cool, I can do that. I can do that. Minus, why, Jeff? Inverse cosine of 4 over 7. That doesn't matter. Come on, Jeff. If that wasn't there, relatively easy. That's there, shit. This whole thing is the angle. Oh shit, but so then instead I go, that's an angle, that's an angle. Do I have an identity for sine of A minus B? Yes, so let's see. And to kind of help you, you can go, anytime you see something like this, you can go, okay, sine, let me call this A, let me call that B. Now write down, what's the identity? What's sine of A minus B?
Sine A cosine B minus sine B cosine.
Good, because sine is the nice guy,
Yeah.
takes turns.
Yeah.
What did I call A?
11 over 7.
And isn't that the one we just did a minute ago? Cosine of what do we call B?
Inverse
Cosine.
That piece kicks ass. Because what are these two then?
They cancel each other.
Yeah, so that piece kicks ass. Then it would be minus sine B cosine of A. I say run out of room. Okay. So then each one of these, that one we already did. But do you see how there's 2 triangles I have to draw? Does everybody see how there's 2 triangles I have to draw? Once I draw those 2 triangles, each one of these questions is easy. Why did I have to do this? Because I can't handle both of these together. If I can somehow pull them apart, now I know how to do that. I can draw a triangle, I can get it. I got lucky here. This is awesome. These would kill each other. So that would just be 4 7s. That one we already did, yes. So this would be, did we actually get it to an answer? Yes, we did. This would be 11 square root of 170 over 170. Same problem, right? Yeah. That's what that is. Times 4 7s. Minus, and then I have to do this, and I have to do this. Are you semi with me? Does everybody understand now? This question. You want many of these, and I'm not going to give you many, too bad. I'm going to give you a few. You look those out, you do them, kick ass. This problem is one step away from being several of that relatively easy problem. I just have to apply an identity. I can't handle these 2 at once. So let me break it up into parts so I can handle each part. Each part I can handle. Okay, bye-bye. So coming back, what was the original question? Let me see. Oh my gosh. Number what one?
90.
There it is. Okay. So coming back to this. So this one would be nice because I could use cosine of A plus B. This one is a identity you don't have to memorize. You can just look it up. And just remind you guys, I don't have to memorize either, which is why I don't make you memorize them. But if you look up what's the tangent of A plus B, you just look it up. If you memorize it, that's great. You're not going to get bonus points from me. I'm just going to look at you weird. We have to go back ways. Double angle. Here we go. Sum and difference for sine and tangent. You could also have that green sheet sitting next to you, right? So here's the sum and difference for tangent. You don't have to memorize them. If I put them on a test, I will give you this formula, and then it just becomes plug and chug. Yes? Just becomes plug and chug. So what would I do first on that problem? Me, if I saw this problem, first thing I would do is draw two triangles. Next thing I would do is rewrite it with the identity. Now I've already got my triangles. I could do each step easy, right? Let's do the first couple steps. Can you guys take a minute? Well, actually, this first piece is kind of silly. Do you guys see why this piece is silly? Do I have to draw a triangle, really? What is the inverse cosine of rad 3 over 2? Who knows?
30 degrees.
Pi over 6, I love it. So I can rewrite this as tangent of pi over 6 minus this weird ass dude.
Yes.
That's cool. Is this good? Okay. So what triangle can you draw from this? Go ahead and draw that triangle. Sorry, I'm zoomed in a lot. Draw the triangle from this. Or don't. It's up to you. Somebody's looking at me like, oh, okay. For inverse sine, you guys remember what the outputs can be between?
Negative pi over 2.
Yeah, negative pi over 2 to pi over 2. Since it's negative, I must be in the fourth quadrant. Do you guys agree? Okay, so I know I'm in the fourth quadrant. So where's negative 3 go in this triangle?
The y.
The y, because we're talking about sine. And of course 5 goes here, which makes this nice. 4. I love it, because you got 3, 4, 5 triangle. I love it. So if I call this A and I call this B, so this is B. Let me zoom out a little bit and just really zoomed in. What's the tangent of B? Sorry, say it again. Sorry.
Negative 3, 4.
Yeah, negative 3/4. Is that cool? And this is A, so what's the tangent of A?
Rad 3 over 3.
Yeah, it's rad 3 over 3. I love it. So now when you do tangent of A minus B, and you look up the identity, you already know what tangent A is, and you already know what tangent B is, so you just got to plug those numbers in. A lot of kids. So again, you don't have to memorize the tangent identities. If I ask you a question about them, the identities will be on there. Anything else from homework stuff? Yes.
Number 68 on from 5-4.
68?
Yes.
Oh, okay. This is one of our favorites. Identity verification, right? So, this side, are there, so what do I look for? What's really tripping me up is I'm doing this exact thing with my pre-calc class right now. Here, you ready? Those of you who like to take notes, not a bad idea. Here's the list of things. When I give you an identity problem, you first look for any immediately obvious trig identities. For example, can somebody tell me one that's in number 68?
Sine x plus y.
Yeah, sine of x plus y. There's an identity for that, right? cosine. There's an identity for that, so maybe I can rewrite those. Second, you look for any immediately obvious algebraic things you can do. Are there two fractions you can combine? Is there something you can multiply out? Is there something you can factor, right? Third thing, you look for anything squared, because that's related to a Pythagorean identity, right? And then the fourth thing would be, if you have no idea what the hell to do, you just make everything sine and cosine. Now, sprinkled around the edge of that, somewhere there you can put this. Let me see if you guys are cool with this. On the left-hand side, what are the angles that the trig functions are doing something with on the left-hand side? No. So on the right-hand side, the angles are x and y. So everybody agree? Neither one of those angles is on the left-hand side. What are the angles on the left-hand side? One angle is x plus y, and the other angle is x minus y. So the only way I could show these dumb things are equal to each other is if they end up with the same angles. Does that make sense? So another big clue is, if I see anything that's 2x and everything else is x, if I see 1/2 x and everything else is x, if I see x plus y and everything else is x, or what, I want to do the appropriate things to kind of like take that away. I could do the double angle formula if it's 2x, and the half angle formula is 1/2 x. I could do the sum or difference if it's x plus y. You guys kind of with me? So I would attack that right-hand side first. Rewrite the top, blah, 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 blah. Rewrite the bottom, blah, 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 blah. And just see where to go from there. Whoever asked me this question, did you try something yet, or did you just look at it and go, I have no idea? The second thing's fine if you did. I don't blame you on some of these.
I did try something, but I went with the left-hand side.
What'd you do on the left-hand side? Because yeah, you could
sine and cosine identities.
Which one? Sorry.
The sine and cosine identities. The sine of A, cosine of B.
Oh no. So that's what I'm saying. Start with the left-hand side. I'm sorry. So you didn't start with this side. I'm just saying start with that side.
I didn't do anything with the right-hand side.
Oh, good. That's fine. That's fine. Yeah, I didn't say to try to do anything because there's a few things you could do. Yeah, I would write sine x, cosine y, plus sine y, cosine x. And do the same thing to the bottom, just see kind of what will happen. So that's what you did?
Yeah.
Okay. So can everybody take a minute and rewrite this side using the identity for the top and bottom there? While you're doing that, I can get some stuff back here. Bourgeois, Daniel, Benson. Why it's not here? Chat. Gene. There. Shayna. Isaiah. Christian. Lauren. Oh, that's what that is.
So,
Break down.
so for the corrections, can I make some more corrections?
Say again? Sorry.
For the corrections I made for the test, can I make some more corrections?
No.
Oh.
Yeah, I don't teach English, so I don't do first draft, second draft.
Oh.
It's probably a good thing I don't teach English. Kai. Oh, that's you. Maximum, no. Okay. Flush. All right, let me catch up to you. So how do I rewrite the top of this?
Sin x cosine y.
Yeah, sin x cosine y,
Sin y cosine x.
sin y cosine x, 11th. They take turns. Of course, cosine is the jackass. So cosine,
Sin x.
so the cosine x, cosine y,
Plus
plus
sin x sin y.
sin x, sin y.
In this case, it might be helpful that cosine is a jackass.
All right, let me see. How do I keep track of all this? There's too much going on. Okay. So keeping an eye on this side. Do you guys notice? Do you see how? All right. There's a top and a bottom. There's a top and a bottom.
Yeah.
This is the part I think students have the most issue with, which is unfortunate because this is the strongest, best frickin' thing about identities. You have a target. So I'm working with this side, and my target is that side. Yes? Do you see how there's a 1 right there? And do you see how so for example, so I could divide by cosine x, cosine y, and make this a 1. So if I divide everything by cosine x, cosine y, there will be a 1 here, correct? But what would I make over here if I divide by cosine x, sine y? I would make 2 whats? Sine x over cosine x, sine y over cosine y. I'd make 2 tangents. What am I supposed to have on the bottom?
Cotangent.
Alright, so instead of doing division by the cosines, I'm going to do division by the sines. Do you see what I'm saying? Because if you don't do that, I would totally understand if you're like, I don't know what the shit to do from here. Jeff, Mr. Math Man. So what I'm saying is, I know there's supposed to be a 1 on the bottom. If I just make a 1 show up in the bottom, I must be going in the right direction. I have to be, because there's a frickin' 1 in the bottom on the other side. So if I divide every term, so this gets a little messy, but I know I'm going the right track. If I divide every term by sine x, sine y. So we're just going to write this big ass fraction, right? Everybody cooperate. Okay. Sine x, cosine y, divided by sine x, sine y. Sine y, cosine x, divided by sine x, sine y. Over cosine x, cosine y, divided by sine x, sine y, plus sine x, sine y, divided by sine x, sine y. So I've divided each thing by sine x, sine y, because I know there's supposed to be a 1 on the bottom. That to me was always the coolest part about this, and I know I'm a geek. I'm well aware of that. But I love that shit. I'm like, if I could just force this to show up, everything else you kind of shake out. So on the bottom I get plus 1, yes?
Yeah.
And what's cosine x over sine x?
Cotangent.
Cotangent x. And what's cosine y over sine y? Cotangent y. What's sine x divided by sine x? What's cosine y divided by sine y? What's sine y divided by sine y? What's cosine x divided by sine x? Why did I do the whole damn problem for you? I don't know, because I was excited. Did I get the other side now?
Yeah. You just have to rearrange the bottom, but yes.
Yeah, exactly. I just have to turn the bottom around.
Yeah.
Right? So I did get the other side. So I need you to understand, a lot of these problems, there's no way in hell you would know the next step if you didn't use the fact that you know what it's supposed to look like eventually. I know it's supposed to look like this eventually. Let me use that to my advantage, right? You guys get that at all? So the very first step, I think everybody should be at a point where you would agree, that is the most obvious thing to do. Rewrite those.
Yep.
The next step is not as obvious. Yes, good.
So when you're dividing your sine x cosine y divided by sine x sine y, your sine x just becomes 1, right?
Yes, sine x divided by sine x is 1. Sine y divided by sine y is 1. This divided by itself is 1. Yeah. That's kind of awesome. A lot of stuff cancels.
So, since this should be relatively easy, can you, like, give, like, a tip as to how you know, like, which side to choose type of thing?
Oh, okay. In this specific problem, there's not, the only thing I really could do with this side, which actually, if you wanted to, you could start with this side. But can anyone tell me what's the only real thing you could do to this side that would make any sense?
Reciprocal identities.
Say again?
Reciprocal identities.
Not really reciprocal identities. Well, not really, no.
Just make them sine.
Rewrite everything in terms of sine and cosine.
Yeah.
But the thing that told me that at some point I have to do this is because this angle is completely different from these.
Yeah.
So I need to rewrite these in terms of x and y alone. So this one is the immediate, I'm like, I got shit I can do. I've got identities I can do right away. Now to be honest, after I did that, if you weren't sure what to do, then you can come to this side and rewrite everything in terms of sine and cosine.
Yeah.
And to be really, really honest, I think that would work. If you rewrite everything here in terms of sine and cosine, and you start trying to put stuff together and so forth, you will eventually make it look like that. Okay, maybe. Yes?
So, I didn't divide by sine x and sine y.
Yes?
After I rewrote the left-hand side.
So you got this here, right?
Yeah.
Okay. What did you do next?
I went on Google to get some extra help, but I came across something that said that, like, you can write tangent in as sine times cosine.
No, you can write tangent as sine times secant. You can't write tangent as sine times cosine.
Okay.
So I'm not sure.
But, yeah.
If they said sine times cosine, maybe don't go back to that place. But I'm almost certain they said
Yeah. So
sine times secant or something. I don't know.
no, it said sine times cosine. I may have read it wrong.
But you with me? Because tangent is by definition sine divided by cosine.
Yeah.
So wouldn't that be inverse tangent?
Say again?
So could sine times cosine be inverse tangent?
No. No. Guys, watch this. Watch this. So maybe the inside wasn't x. Maybe there's some weird little thing they were doing with that. That could be true.
Well, if you want, I'll show it to you after class.
Good. But you guys see this? What is 1 over cosine?
That would be C.
So sine times secant is tangent. Because secant's 1 over cosine, and sine over cosine is tangent, right?
Yeah.
So what's cosine times cosecant? Cotangent. Same way, cosine times cosecant is cosine times 1 over sine is cotangent.
Okay. Yeah, so following the logic of the help I got from Google, that's kind of what I used to verify.
Okay, you have to show me, because I'm pretty sure it didn't say tangent x equals sine x times cosine x, correct? It might have said tangent of x plus y equals sine of x plus y times something or other. Alright, you'll show me, you'll show me. Okay. Alright guys, enough questions. We gotta get back into where we left off. And by the way, if you missed this from earlier, I think at some point I'm gonna run out and print some of these out, but I updated the homework timeline sheet. I made quite a few things I could credit, which is fine, because some of these were actually like extra sections that I sort of put in, because I was, overly ambitious. But we can now just make an extra credit. The next test is gonna be May 6th. We're gonna have a quiz on Monday. on 5.4 through 5.6. Okay. So we left off, and you're gonna have to really excuse me because I'm teaching the exact same stuff in my pre-calc class. So the idea of where we left off is completely like out of my brain. But we did start talking about solving trig equations, if I remember correctly, yes.
I got a thing in my email saying that there's supposed to be a vote for tomorrow.
There's supposed to be a
Vote going on tomorrow?
vote tomorrow. I don't know.
Well, then I think the next part of my question moved then.
Is it a vote for what?
That, I don't know, I was gonna see if, keeping the.
Is it the ASG, maybe, student government vote? I don't know, I'm not keeping up with that.
Said, ASGG or.
Yeah, it's a student government vote,
Okay.
right? And I'm almost certain some of you guys are like, student what? So we do have a student government, and they do have positions open. And their members sit on the governing board too. These are the people that set up all the rules for both Quebec and Grossmont. So there are student trustees on the governing board that sit with the people that the other people elect to those positions. So it's a really good experience. But I understand some of you guys are like, I can't even keep up with my homework, dude. I'm not going to add that. I understand. So yeah, apparently there's a vote for that tomorrow.
Yeah.
I didn't even know, to be honest.
Yeah, which makes the next part of my question move.
Okay. So remind me, guys. Did we start talking about? Well, first off, let's do this. We already did some problems with the inverse trig stuff. So, and I gave. Has everybody got one of these sheets? Where would they be? The green sheet, right, with all the identities on it.
Yeah.
If you don't know what I'm talking about, you might need it. This guy. Does anybody need this? Okay. Let me leave this here so let me know if anybody else needs that. So if I am a student in this class, I definitely have this sucker sit next to me as I'm doing identity sections, verifying identities. The only thing you don't currently need to memorize above this black line are these two things. These two things are in our future. Everything else here you must memorize. Everything below the black line, if I ask you a question about it, I will have the formula on the test or the quiz or whatever. Okay. I like it. Okay. So this is a very key part right here. Yeah. When you do an inverse sign of something, it can only give you answers in which quadrants?
1 and 4.
Yeah, quadrant 4 and quadrant 1. Inverse cosine can only give you answers between quadrant 1 and quadrant 2. And again, why did we do that? We did that. We made that happen.
Yeah.
Why did we do that to ourselves?
Just to pass the horizontal.
Mhm. If I leave a sine and cosine alone, do they pass a horizontal line test?
No.
No. So I had to chop it somewhere so it did pass a horizontal line test, which means I could create the inverse in the first place. So we had to do this to ourselves to even have it exist. So the trade-off now is if I know I'm supposed to be in the third quadrant and I do an inverse cosine of something, will the answer be in the third quadrant? No, it's impossible. It's going to give it to me in the first and second quadrants. So the answer to an inverse trig function can at worst be a reference angle. And then I have to get it into the correct quadrant. Are you guys kind of with me? So this kind of question is very evil. Nah, not very evil. It's semi-evil. What do you got, Jeff? You can do it, buddy. Oh, I'm doing this backwards. Am I? Wait, let me think about it. Hold on. Which kind of question do I want to give you? Yeah, that's right. That's right. What do inverse functions want to do to each other?
Inverse, or
So what would those would want to kill each other, correct?
Mm.
The answer cannot be 4 pi over 3. And we just talked about why. What's the output for inverse sine? It goes from negative pi over 2 to pi over 2. By the way, real quick, what is cosine like, x or y? So here's cosine is x. So the output for inverse cosine is from the x-axis, from 0 to pi, x-axis. Output for inverse sine, negative pi over 2 to pi over 2, y-axis. Yes? Okay. So now, can somebody tell me very quickly why the answer cannot be 4 pi over 3? What quadrant is 4 pi over 3 in?
The third.
Third quadrant. And inverse sine can only give me answers that are in the fourth or first.
Well, you can use that as a reference angle.
Beautiful. Somebody tell me. Sine of 4 pi over 3, would it be positive or negative? I don't even care what the number is. Would it be positive or negative? Because it's in the third quadrant, correct?
Yeah.
The output for inverse sine can only be fourth or first. In which one of those quadrants is it negative? So I want an answer in the fourth quadrant, correct? What's the reference angle for this?
Pi over 3.
So the answer is going to be, the angle's got a pi over 3 reference angle, but it's in the fourth quadrant. So what's that going to be?
Negative pi over 3.
Good! Negative pi over 3. I love it. I was going to take 5 pi over 3, but then it has to be between negative pi over 2 and pi over 2. So negative pi over 3. I love it. You would, Jeff. It's because of how we had to chop it that these can't just kill each other and this is the answer. The answer's actually got to be in one of the quadrants it's allowed to be in. Okay, I like it. And I almost feel like, whenever I say something like this, you're all like, what else can happen, Jeff? Good Lord, man. Okay.
Now, if instead it was, instead of 4 pi over 3, if it was pi over 3, that would thus be the answer.
Yeah, that would be the answer, because that would be allowed. So if I had inverse cosine of the cosine of 5 pi over 6, is that an allowable angle output for inverse cosine?
Yeah.
Yep, so the answer is 5 pi over 6.
Yay!
Okay. So one little thing to be careful about when you're doing these inverse stuff is what the outputs are allowed to be. Okay. So I can't remember, but let's see if you guys can help me remember. Let's do this. Sine theta equals 1/2. Have we discussed how to solve this equation yet? Does anyone tell me one answer to this equation?
Pi over 4.
Negative pi.
Careful. What? No? Say.
Pi over 4.
No, because that would be, what's sine of pi over 4?
2 over 2.
Right, 2 over 2. So not 1/2, correct? So I need an angle that would make sine become 1/2.
Pi over 6.
Yeah, pi over 6. So one answer would be pi over 6. What's another answer?
4 pi over 6. Oh, sorry.
Because
5
where
pi
else
over
is sine positive?
Quadrant 2.
Yeah.
5 pi.
So if I have a reference angle of pi over 6, so what other angle?
5 pi over
5 pi over 6. All right, you stop for a minute. So, in one sense, this makes sense because if you're supposed to know what the sine of pi over 6 is. So there's an old adage about if you know it backwards and forwards, you know it. This really, on one level, this is just do you know it backwards. So the question is, what angle makes sine become 1/2? That's the question. So pi over 6 is the immediate answer, but there's another answer within 0 to 2 pi. So we're still not done with this, by the way. Go ahead.
I had gone to the math study center yesterday. During homework, and I remember them mentioning something about if you have like infinite.
Yes, totally. We're about to get there. We've only got 2 answers. Can't I just keep rotating
Yeah.
forever? So aren't I going to come back to this point at some point? How far do I go to come back to here?
2 pi.
2 pi. I love it. So, can I only do that once? Can't I keep going? And going, and going, and going,
And you're rejected by
and going. So every time I do it, I'm gonna do a full rotation to come back, yes? You guys all with me? So therefore I can add, I can't remember this book, if it has a K or an N.
I think it's K.
Is it K? Okay,
Because I remember K.
thank you. Now, to be honest, K is normally considered to be an integer, so it could be negative, but I like to make it really obvious. I could also rotate backwards, yes? So I'm gonna put plus or minus. So all this frickin' says, if I ask you, real quick, on the side, if I ask you what is the sine of 13 pi over 6? Help me out. How would you figure that problem out? What would you do first? Yeah, find the reference angle. In fact, part of the question is really, where the hell do you end up when you rotate by this much? If I spin around that much, where the hell am I facing, right? Can anyone figure out where I'm going to end up? Yeah, because what's 2 pi would be 12 pi over 6.
Yeah.
So I went 2 pi, I went a full rotation, and then a little bit extra, and like you said, I went pi over 6 extra. So isn't this equal to sine of pi over 6 just directly, because 13 pi over 6 is freaking pi over 6, yes?
Yeah.
Okay, cool. So all I'm saying here is, if I put pi over 6 in, this works. If I put 13 pi over 6 in, it still freaking works, because I'm going to end up in the exact same place. I'm going to have the exact same triangle I can draw. If I end up facing here, I've got the exact same triangle. It's got the exact same sine. Okay, maybe. And I can do the same thing to this angle. So this also gets a plus or minus 2 pi k for exactly the same reason. Okay. Yes?
If we use n, it doesn't matter for you?
Oh, yeah, if you use n, it's fine. I just couldn't remember. I'm really bad about knowing what a book does because I don't look at the book too much, to be honest, but I just know shit. Let's see.
Reference use
6-2. What do? They use. Come on, guys. What's going on? Do they use anything? What the hell? Learning seems to be within 0 to 2 pi. That's not great.
I think they use n, because when they use the
6-3. Is that where this lives now? That sucks a little bit, but that's okay, John. Here it is. Yeah, they use n. Yeah, okay. So to be consistent, I'll use. It doesn't.
Yeah, it does.
All that k means is some integer multiple of rotations. So all it says is, if I rotated once, if k is 1, it's still an answer. If I rotated 30 times, if k is 30, that's still an answer. Yeah. Okay. And if I only want answers from 0 to 2 pi, then that would just be what? So these are all the answers.
I've done on rotation.
Yeah, this would just be pi over 6 and 5 pi over 6. So the answers in 0 to 2 pi, I sometimes call them the base answers, because then I can build all the other possible answers off of those. Okay. So, real quick. Everybody has to be cool with that part of this problem, correct? Because we all know which angle makes sine 1/2. Then you realize there's at least one more answer. There's another angle in one rotation that makes a positive sine 1/2, and that's the same angle that's back here. So that's 5 pi over 6. And then you go, holy shit, if I just keep rotating forward and backwards, I can get answers forever. So there you go. That's all the answers. Now, yeah, I do have a handout here. I'm gonna give you in a minute. Yeah, let's see. Does it get too weird, freaky? A little bit. That's fine. Okay. By the way, this is gonna sound a little weird possibly, but par for the course. Is this distance the same or different from this distance?
Different.
This distance, they're different, correct?
Yes.
So therefore, I was not able to write all the answers in a single line. I had to write them in 2 lines. Because the steps I gotta take won't pick up the other answer on the way. So what the hell am I talking about? Let me show you an example where I can write it in 1 line.
I was just gonna ask.
I got you. You're gonna ask exactly that? Okay.
Mm-hmm.
So what if I had this problem? Sine squared x equals 1/2. What do you think you have to do first?
Square root.
Square root it. I love it. The first one was relatively easy because the sine equaled a number. Great. So go ahead, square root it. Time flies. Square root. When you do a square root, you got to do what?
Plus or minus.
Plus or minus 11, right? Real quick, just in case, I'm pretty sure that must have come up by now. I know it has, but just to remind you guys, if I said what squared is 9, and you say 3, you're not done, right? So when I take a square root, I got to put plus or minus to get all the answers. Okay. So this will be, I'll do this. So sine x equals, what do you get over here? Plus or minus rad 2 over 2. I love it. Because you get 1 over rad 2, and if you rationalize it, you get that. Does that number look familiar?
Yeah.
Totally. So can somebody give me one answer for this? In radians. Yeah. Pi over 4. I kick ass. Right? That's that question by itself has to be easy. Now I'm obviously not done for 2 reasons. That makes positive rad 2 over 2, but it also could be negative rad 2 over 2. And there's more than one place that makes positive rad 2 over 2, right? So what's another option? What's another answer? 3 pi over 4. In fact, you're going to get all of the...
5 pi over
That'll make it negative, right?
7 pi.
And that'll make it negative. Now, do I have to do a plus or minus thing off of each of these? No, I don't. In fact, I didn't really even write these. I'll show you. So doesn't it happen at every 45-degree angle, every pi over 4? Yes?
Mm.
How far apart are these 2?
Pi over 2.
They're 90 apart. 90 degrees. Pi over 2. I love it. And then these 2?
Pi over 2.
Pi over 2. Pi over 2. Pi over 2. So instead of starting at one answer and taking full rotations to get another answer, I can take a quarter rotation, quarter rotation, quarter rotation, quarter rotation, quarter rotation. I can pick up all the damn answers on the way. I don't have to write 4 separate statements. Right? Screw you. I can do, start here, go forward or backward, some multiple of what? Pi over 2. Because they're all 90 degrees apart, right? They're all pi over 2 apart. Plus or minus pi k over 2. I'm going to do k, by the way. Even the book does end because I'm just so used to k. I'm probably just going to do that. K and n both mean the same thing. It just means the number of rotations you want to do.
It's kind of like saying the angle is called theta or beta or gamma.
Totally. Yep. Yes.
So previously with the 2 different statements for that, can we put like this or this plus or minus the rotation?
Oh, like up here?
Yeah,
Yeah, it's sort of been implied or here, but yeah, you could write or.
like in one line, you can just put.
Oh, sure.
that
This
equals-
or this in one line. Yeah, that's fine. Yeah. Okay. So here I do have 4 what I would call base answers that live in one rotation, but I don't need to build off of each of them because I got lucky. All my freaking angles are exactly the same distance apart. So I can pick them all up. Maybe. So here, you guys do this. Well, let's do one more together and then I have a handout. Yeah. What's the kind I want to do? Yeah, it's true. Yeah, I gotta do two kinds. Okay. So watch this. What about if I gave you this? And you're all like, okay, you gave us that. What the shit do I do? Can you guys remind me, how do you solve this equation?
Factor out an x.
Yeah, take an x out.
X equals 0.
X equals 0, x equals 1. You guys remember that, right? It's r equal to 0, you factor it, and then either this has to be 0 or that has to be 0. Does that sound familiar?
Yeah.
So what can I do here? What comes out?
Factor out a sine.
Yeah, sine x comes out, right? I had two sines, I took one, so I have
Sine x minus 2.
one sine x left. I had a 2 times sine, I divided a sine out, so I just have a 2 left. So I want to do this problem for two reasons. One is factoring is going to become a possibility. And the other one is, all right, let's see, what can I do from here? The only way that this number times this number can be 0 is if one of them is 0, yes? That's why this side has to be 0. So either this number is 0 or this number is 0, yes? So when is sine 0?
It's at 0.
At 0
Or pi.
or pi? And just a real quick thing. Here's 0, here's pi. If I move around, do I have to go the full way or can I pick up an answer as I go?
Pick up an answer.
Do you guys see that? How far apart is 0 and pi? Pi. How far apart are pi back to 0 again?
Pi.
Or back to pi. So if I just go forward or backward a multiple of pi, I pick up all the damn answers. So I don't need get out of here. I just do 0 plus or minus pi k. So I get x equals pi k. 0 plus or minus anything is, I'm sorry, plus or minus pi k.
We're getting pie and cake? Cool.
Huh?
We're getting pie and cake? Cool.
Oh man, that's the best. I always hate trying to decide. Depends on what mood I'm in. I'm always in the mood for both. How about this guy? How do I solve this guy?
Add 2 to both sides.
Add 2 to both sides. Can anyone tell me right away that you don't have to do any more work? You guys see why you don't have to do any more work? Can sine ever be 2?
No.
No. No solution to this part. So the answer to this equation then is just this. Because the other part gave me nothing. Stupid other part. You give me nothing. Yeah, okay. Let's try this. One more type, and then I'm going to let you guys try a few out. We already sort of did this problem, so I'm going to kind of... We sort of solved this problem already. Right? We solved sine of an angle is 1/2. What's got to be true about the angle? It's got to be one of these two things, correct? So I need you to understand. Would the answer have changed if I would have put a alpha there?
No.
No.
I would have just said alpha, alpha, right? What if I would have put a beta there? Beta. It would have just said beta, beta, right? So what if I put 2 theta there? No, 2 theta is this, or 2 theta is this. I need you guys with me. I know sine of something is 1/2. What's got to be true about that something? It's got to be this or this. Sine of this equals 1/2. It's got to be true about this. It's got to be 5 or 6, blah, 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 or it's got to be 5 pi or blah, blah, blah. How do I know I'm not done yet, of course? Because I'm trying to solve for the variable theta. So what do I have to do to both of these statements?
Divide by 2.
Divide by 2. So here's the nice thing. When I divide by 2, if I have a fraction, dividing by 2 is just multiplying by a half. Right? People always freak out a little bit, but if you have a fraction divided by 2, just multiply by half. Kicks so much ass. So what does this become? Pi over 12 plus or minus pi k. And this becomes 5 pi over 12 plus or minus pi k. Very quickly, let me see if you guys remember. Another reason this makes total sense for this right here, most of the time it's going to be a 2 pi for sine, because what's the period of sine? What's the period of sine? 2 pi. What's the period of sine 2 theta? What happens to the period? Don't you take the old period divided by k here, right? So 2 pi divided by 2 is? Pi. So that makes sense. That's going to repeat itself every pi. Okay, so let me finally shut the hell up. Dear God, Jeff, you talk so damn much. Let me have you guys work on these. Just try out the first 3. Might be all I have time for. Want to, we can work together.
Okay, so just do 1 A, B, and C.
Yeah, A, B, C. Do the first 3. Yeah. And pay attention. Sorry, I don't mean to say it like that. I just want the ones that are in 0 to 2 pi. You don't have to do the plus or minus thing on those. Okay. Just to give us a place to start. First one. If you are not drawing pictures, you're not going to lose points, but I don't quite understand you. Pictures help us out so damn much. Before I do anything, what quadrant will the answer need to live in? 2?
2
and 3.
Yeah.
I do that just to kind of like, as I go into it, I know the answer should end up in those quadrants. So cosine of what angle gives me rad 3 over 2? Pi over 6, but then I know I'm supposed to be in these two, so I want to be pi over 6 before pi and pi over 6 after pi. So what's pi over 6 before pi? 5 pi over 6. That's 1/6 of a pi, less than a full pi. Pi. What about pi over 6 past the full pi? 7 pi over 6. 11. Now, if I would have not put this, if I would have just said solve, then you would have had to put plus or minus blah, blah, blah. Now, some of you guys did beautifully here. You already did the work. You know that this is this. So therefore, x would be 5 pi over 12, 7 pi over 12. Now here's the frustrating thing. You ready? That's not all the answers. Since I'm cutting everything in half, I'm going to pull in more answers than that. So watch this. So here's a good way to do this. So 2x is 5 pi over 6 plus or minus 2 pi k, right? Or 2x equals 7 pi over 6 plus or minus 2 pi k. Now listen, I know I didn't ask for this, but watch, whenever you have an angle inside that's not just x, you're going to want to do this, and I'll show you why. I know some of you guys got these answers, yes? These answers are correct. You're just not done yet. There's more answers. So, sorry, problem. I'll do you another piece of paper. So this would be x equals 5 pi over 12, give or take pi k. And this would be x equals 7 pi over 12, give or take pi k. So if I make k 0, I get 5 pi over 12 and 7 pi over 12, yes?
Mhm.
What if I make k 1? What's 5 pi over 12 plus pi?
17 pi over
Yeah, it'd be 12 pi over 12, it'd be 17 pi over 12. First question, does everybody understand what the hell I'm doing? I really just added one of these on top of this. Is that still between 0 and 2 pi?
Yeah,
What would 2 pi be? It would be what over 12?
24 pi.
24 pi over 12. That would be 2 pi. So isn't 17 pi over 12 still inside here? If I have an angle that's more than 2 pi, so 3 pi, and I divide it by 2, I get 3 halves pi. Doesn't that live between 0 and 2 pi now? So if I take any angle between 0 and 4 pi and divide by 2, it'll live between 0 and 2 pi. That's why I'm getting more answers. Since I'm cutting it in half, I'm pulling more in to live between 0 and 2 pi. So what's the other answer I get? If k is 1, I get 7 pi over 12 plus pi. So I get 12 pi over, so I get 19 pi over 12, which is still less than 2 pi. So if I had a 3 here, I'm going to triple my answers. I would have 6 answers then.
Yay.
Okay. So we're obviously going to do more examples of this, but I just want to lay that groundwork as to why that's going to happen sometimes, yeah.
And you would just add 2 pi over 3 for the, if it was 3x?
Oh, if it was 3x, yeah, then it would be 2 pi over 3m. Yeah. You do all the same work. I'm just trying to show you how to expect how many answers you might get. Okay. One little thing, it's a little side note. Whatever number that is, do you see how we had to go up to k equals 1? If we go to k equals 2, 5 pi over 12 plus 2 pi, that is obviously more than 2 pi. So I wouldn't do it. If I had a 3 here, then I would go up to k equals 2. If I had a 4 there, I would go up to k equals 3. So that is one generalization you can make. And again, guys, it's okay. We're just starting to do this stuff. I'm trying to show you the stuff that could happen. We're going to do more examples. So I'm just trying to show you the stuff that could happen, yeah.
So, as it pertains to cosine of 2x, the 2 actually represents the number of answers, or number of possible answers.
Well, we got 4 answers though, right? So the 2 kind of represents how far you want to go in the k.
Yeah.
So for the first problem, I just had to go 1. K equals 0, right? Just had to go. For the second problem, I had to go k equals 0, k equals 1, because there's a 2 there, right?
Okay.
Now, real quick, did anyone think they got this third one done? I can't remember if I gave a hint on this, the fact that the angles are different. Did you? Oh, I'm sorry.
Yeah,
Say-
it was x equals 0.
No, well, what's the first step here?
Oh, divided by sine.
No, definitely not. No.
That would be x equals 2x. Yeah.
Is there a sine x on this side? Nope.
There's a sine.
There's a sine 2x.
Mm-hmm.
There's a sine also, but you can't divide the sine away.
You could, multiply that.
Right? It's sort of like if I said solve this, and somebody said, okay, there you go. X is 7 divided by square root. Next problem, Jeff. This math stuff is easy.
Sorry,
So you
multiply by the
can't
integral.
divide by a function notation, right?
Yeah,
Yeah.
multiply
Do
by-
they talk about the same angle?
Yes. No.
Do they?
No, no.
So this is talking about x, this is talking about twice that.
Yeah.
Don't I have an identity for this? What's the identity for sine 2x?
Sine 2 sine x cosine.
2 sine x cosine x. Right?
Okay.
So then I can subtract sine x, get it equal to 0, so then I can do what?
Factor out.
Factor out a sum. This is awesome, Jeff. I was wondering how much better your class could get. All right, now real quick, I'm sorry. There is some algebra in this class. There's not a ton. We haven't seen much algebra at all, so some of you guys are like, ooh, I love this. There will be some algebra, there must be, especially when we're solving equations, because algebra is like, that's my jam, what are you talking about? So there will be situations where I must use some algebra, and the most basic one we're going to use is factoring, because that's what's used when you solve equations. So what's got to be true? Either sine x is 0, or 2 cosine x minus 1 is 0. So this one we did earlier. I don't know if you guys remember, that's plus or minus pi k, yes? Because I get 0 or pi, we did that earlier. Here, if I solve for cosine, what do? I add 1,
Add 1/2.
divide by 2. So when is cosine equal to 1/2?
Pi over 3.
Yeah, pi over 3, or? No, it's going to be positive 1/2.
Negative.
So when is cosine positive? Whenever the x-axis is positive, that's first quadrant,
Plus
fourth
or
quadrant.
minus. Plus or minus 5.
No plus or minus.
Oh.
Yeah, 5 pi over 3. Good. So those are my, well, I should have put this then. What's the two answers for sine in 0 to 2 pi that make it 0?
0 and pi.
0 and pi. So my answers for this, those are my answers for this. Because I specifically said 0 to 2 pi. Alright guys. I will stop torturing you. That's enough. On Monday we'll have the quiz. We'll finish up this section. I'll have the practice test. Because our test is May 6th. Let me make sure I got my time frames right.